Hi, I'm Nick, and in this video I'm going to show you how to use a signal generator to blink an LED. I'll use the nLab to generate and see the signal and play around with the different settings in the app. An electronics lab needs at least 3 machines. First, you need a power supply to power all of your circuits. The second thing we need is a signal generator. That's a device that can output a signal that we feed to our circuit to see how the circuit will behave. The last device we need is an oscilloscope. An oscilloscope will read in signals. That way we can visualize exactly what is happening inside our circuit. In short, the oscilloscope makes invisible things visible. We can't see or feel or touch electricity, but the oscilloscope will be able to sense it for us and show what's happening. The nLab is all of these tools in one device. First, it's a power supply. It generates positive 5 volts and ground and puts them into the breadboard on the right side, and negative 5 volts and ground and puts them into the breadboard on the left side. It is powered by your computer and controlled by the nLab computer app. The app lets you change the settings of the nLab and see the signals. In this activity, we're going to use our signal generator to make a signal that goes into our LED. We'll change the properties of the signal so that the LED blinks, and then we'll view it with our oscilloscope to verify that it blinks the way we expect. These pins on the left, A1, A2, P1, and P2, those are the signal generator pins. The pins on the right, CH1, CH2, CH3, CH4, those are our input channels to the oscilloscope. Putting a wire from our circuit into the CH1 row means that we'll be reading something about the circuit on channel 1. Putting a wire into the row for A1 can take a signal out of A1 from the signal generator and put it into our circuit. For instance, I could use a wire to connect A1 directly to channel 1, and then we can turn on the signal generator in the app and see the signal. So I'll quickly make a wire. I'll take a purple wire, cut it with my wire strippers, remove the insulation on either side, and directly connect the row from A1 into channel 1. In the app, I could turn on the signal generator at A1 by clicking the A1 button. The default signal is a 1 Hz 1 volt sine wave. A sine wave is a smooth curve that repeats. I can change its amplitude, which is how tall the sine wave is. A bigger sine wave might make a brighter LED. I can also change the frequency of the sine wave. That's how often it repeats. If I make the frequency higher, the LED might blink faster. We'll see how the amplitude and frequency of the signal generator affects something like an LED in a second. We can also change the shape of the signal. We can change it from a sine wave to a triangle wave. Now the signal is made of little triangles. In a bit, we'll see how that changes what the LED looks like as it brightens and dims. The green triangle on the right represents 0 volts. I can also change the signal from unipolar to bipolar. Bipolar means that the signal will go above and below 0 volts, so we'll get a positive and a negative signal. Unipolar means that the signal is always positive. We'll see how that affects the LED too. The horizontal size of the squares represents time. Right now, the time is on 200 milliseconds per division, which means that each of these horizontal squares represents 200 milliseconds, or 1/5 of a second. So let's use A1 to blink an LED. First, we'll turn off the nLab. The wire from A1 to channel 1 that we put in earlier is still there. We still want to see what A1 is doing, so we'll look at it on channel 1. Now we'll build the circuit. We're going to take our red LED and put the long side into A1. The short side will be in some unused row. We'll take the resistor from that row to ground to complete the circuit. I would also like to put a wire from where the LED touches the resistor into channel 2. That way we can see what's happening at that point in the circuit. It should be related to how bright the LED is. I'm going to use a green wire for that, so I'll cut a pretty long green wire. But it really doesn't matter what color you choose. We reserve red for power, black for ground. So all these intermediate voltages, all these intermediate signals, we could use any color we want. Now we could turn our nLab back on and go into the app. Let's change the settings to try to make the LED blink. First, I'll click the A1 button to turn on the signal generator, and we have a 1 volt sine wave. But when we look at the red LED, it's not blinking. Why is that? Well, we added the voltage between the resistor and the LED to channel 2. That should represent how bright the LED is. So I'll click on the channel 2 button to turn that oscilloscope input on. And right now we see that it's always 0. So the LED never turns on. We've verified that. It turns out that LEDs have a minimum voltage before they'll turn on. That means my signal generator has to apply a bigger voltage to turn on the LED. So I'll change the settings for A1 to make a larger amplitude sine wave. That means the voltage will have a taller peak. So I'm going to drag that up to, say, 3.8 volts. Now we have a nice big sine wave going into the LED, and we can see it getting brighter and dimmer. The yellow signal in the nLab app is showing us when the LED is getting bright. So it's not always on, but most of the time it's getting brighter and dimmer. What happens if we increase the frequency of the sine wave? I'll go into the A1 settings and I'll bring the frequency to 4.4 hertz. Now the LED is blinking 4.4 times a second. If we drag it even further, here's 21 hertz. It's blinking really fast. And as I make it go faster than that, here's 64 hertz, I can no longer tell with my eyes that it's blinking. It just looks on. But the nLab app doesn't lie. If I zoom in time, I can see there's still a sine wave being applied to the LED. So we know the LED is blinking. It's just that something about our eyes are lying to us. We can't tell it blinks faster than that speed. Hopefully this demonstrates the importance of having a good lab kit, a tool like the nLab that can generate voltages from a signal generator, that can see voltages with an oscilloscope, and can supply power to a breadboard. Until next time, I'm Nick. Thanks for watching.